So we're going to have a look at density and kinetic theory here. It's section 1.3 of the P1 syllabus. So the key to understand density is to know what density is. So density is defined as the mass per unit volume. Now we'll talk about these units in a minute. So it's density is mass over volume. That's what density is. Now, what did we know in key stage 3? Well, not a whole lot, but in key stage 3, what we more or less studied was the 3 phases of matter, which were solid, liquid and gas. And this is linked to density. There's the 3 phases of matter. Now, the solid is the most dense. In other words, the most atoms packed per unit volume, and the gas is the least dense. So when we talk about density, we have to talk here about the unit of volume, and the unit of volume is either the meters cubed or the centimeters cubed. When you were doing key stage 3 work, you often talked about a fair test. The fair test is what mass can you pack in a unit of volume? And that there is your fair test. It's the volume is your fair test. So a cubic meter is a cube of dimensions 1 meter by 1 meter by 1 meter. The 3 tells me it's a 3-dimensional thing. Now again, the centimeter cubed is, again, there's your 3 dimensions. It's 1 centimeter by 1 centimeter by 1 centimeter. Again, quite difficult to draw 3-dimensional shapes on 2-dimensional paper. So this mass is measured either in kilograms or grams. Those are the 2 units that you have for that. So the units of density can be kilograms per meter cubed. Another way of writing that, kilograms per meter cubed, bringing the indice up above the line changes the sign. You could also have grams per centimeter cubed, same rules apply. That's the same thing, that's the same thing, they're all the same thing. So there's the 2 units. Now, there is a conversion from one to the other, and we will do it. You can change kilograms per meter cubed to grams per centimeter cubed. You simply divide by 1,000. Now, if you're doing A level, I'll explain why, but you're not doing A level, so I'll not explain why. So to change grams per centimeter cubed, you multiply by 1,000. And a good way to remember this is water. And water has an density of 1 gram per centimetre cubed, which is the same as 1,000 kilos per centimetre cubed, per metre cubed. So 1 gram per centimetre cubed is the same as 1,000 kilos per metre cubed. Again, the rearranging of this formula always poses problems. Now, the reason I'm writing vol in there is that you don't get it mixed up with velocity. So, no matter what you do in this life, always try to keep it simple. So, 2 is equal to 10 divided by 5. So, 2 times 5 is equal to 10. So, density times vol is equal to mass. And then 5 is equal to 10 divided by 2. So vol is equal to mass divided by density. So there's a simple way of rearranging the formula. So if you can't rearrange formula, that's what you do. Now, for the density, we're going to have to look at find the density of 3 materials. The density of a regular solid. Now, a regular solid is probably a cuboid or a cube. So density equals mass over volume. So the mass you would find on a balance, and the volume you find by measuring the length, breadth, height. It could also be a cylinder, it could be a cuboid. Cuboid, cube, very few cubes in the real world. Lots of cuboid like shale boxes and stuff like that there. Cylinders, spheres. Now we don't do the cylinders and we don't do the spheres, so we wouldn't have to worry about them. So you find the mass using the balance, and you find the volume by measuring it. So and that's your regular solids. Now there are irregular solids. An irregular solid would be something like a stone. Right, so just put in the word stone there. So how do you find the volume? So density equals mass over volume. Yes, we're back to the old scoreboard. The mass again is a balance, and the volume you use a displacement or eureka can. A displacement or eureka can. So what you do is you have your eureka can, which is a can with a spout on it. You fill it up to level. You then put your stone in it. The water, which is equal, flows into that, and then you measure that there, and that gives you your volume. And then you find the density yet again. So that'll do of a solid. Now we're going to find the density of a liquid. The problem with a liquid is that it always occupies the shape into which it is placed. So if we go and look at the density equals mass over volume again, with the mass again we're back to a balance, and the volume is usually a measuring cylinder for a liquid. The thing that you have to watch here is finding the mass of the liquid. You may have to subtract the mass of the measuring cylinder. And the last one we're going to look at, but again it's not really asked, but we'll look at it anyway, is the density of a gas. And again, it could be something like a balloon. So the density is equal to the mass over the volume. So this is quite difficult to do because the mass of a gas is small. You do have balances that can read fractions of grams, but the problem is the volume, because if you start pushing, we'll say, a balloon underwater, you change the volume of it. But again, it's not on our course, so we'll not really worry too much about it. So that'll do this one. We'll see how this goes.